Hey guys, today we would like to talk about how you can deploy machine learning model with Apache SPARK ML using Dataproc and BigQuery. Okay, so our objective of this project is to deploy this machine learning model, which would basically predict the weight of a newborn baby based on few attributes. Okay, so this comes under this BigQuery public datasets. So let me tell you what is basically BigQuery. So if you go to the navigation menu and if you click on BigQuery, so BigQuery comes under the big data. So if you go down, so you can see that BigQuery is here. So I pinned this BigQuery on the top so that I don't have to scroll down. So as you can see that this is the query editor and we can access the data from here. So if I want to query any data, let's say this data set which we would use for this project. So this is basically our query which we would use, and if I click here, as you can see that, so this is same as that of the SQL syntax, and you can see like select and the column names which we would like to select and from the table, and with based on some condition, because we do not want to have any null data in our data set. Okay, so that's why we mentioned this condition. So if you run it, it would say that how much time it would take. So it says that this query would process 5.5 gigabytes of data when run. Okay. Right, so let's have a look at what is BigQuery. So BigQuery is basically Google Cloud's fully managed petabyte scale, all right, and cost-effective analytics data warehouse. And it enables you to run analytics over vast amount of data. So you have already seen this query would process 5.5 gigabytes of data when run. So this is a quite lot of data, and it's just a one single table. So you can imagine if your database contains 500 tables, what would be the scale of the data? And if you click on getting started, so this is how basically you would understand what a particular module is and the best way to read through the documentation. So if you click on quick start, so cloud console selector page, so you basically go to the selector page and select a project and enable the API. This is important for all of these modules. You have to enable the API first, and then only you can use those, and you can query the public dataset. This is basically the original project, and it has so many public datasets, also many from the COVID-19. Okay, and so these are basically all public dataset which you can query. So and I can also check the schema over here. So schema is basically the data about what kind of data we have. So we have the field names, these are the field names, and these are the average humidity, maximum humidity, etc. And the data type is also mentioned. This is string, date is date, and rest of them are numeric, float, or integer. All right, so you can also click to query table, and automatically it shows you this query on your query editor. Okay, so you can see that select which you want to select. Basically you can choose a particular column or all columns, and it has a limitation of 1000 because it doesn't want to get all the data and run unnecessarily. So it says that this query would process 85.8 megabytes of data when run. So in real time it is showing what would happen, and if I run, it would show me the results. Okay, you see the result is quite fast. And yeah, so the thing is that like we chose like 1000 of records, so it is not that big. I can also choose to save results in multiple formats. So I click on save results, and I can choose whatever way we want to do that. Okay, even in Google Sheets we can also save it. Our BigQuery table, what basically we would use in this project. This is basically all about BigQuery, and you can also click on features and info. All right, so let's go to our project now. So first, what we would do, we would do the basic prerequisites completed. Like we would go to the selector page and enable all these APIs, and we would install and initialize the cloud software development kit. Okay, so I go to the project selector page and I click the project which I want to use. And before doing that, I can also choose to create the project. So I go to the navigation menu and I am an admin, and then manage resources, and then I click on create project. So that is how basically I would create project. At the moment I do not want, because I already have created many projects, so I would use one of this existing project. Okay, so I again go to the project selector page and I select the project, and as you can see that I would enable the APIs here. So I can also check whether the APIs are already enabled or not. So this is my dashboard where I can check. Okay, so the API is Dataproc, and I click here and it says that API enabled, so I don't need to do it again. I would go BigQuery as we just saw it, so it must be enabled, and compute engine APIs. Okay. And that's all. The prerequisites are done. No, not yet, because we have to install the cloud software development kit. So this is basically the SDK documentation, and we can choose to install it by click here. As I already have installed it, so I would not do it again. So I'll just open this Google Cloud SDK shell. So as you can see that this bucket is empty already. So if we execute this query gs-util-ls, it would return nothing because there's no file in that bucket. And now we would do the final prerequisite step, that we would create a Dataproc cluster docs. So you can see that Dataproc is basically managed service which is hosted on Apache Spark and Apache Hadoop, and it lets you take the advantage of these data tools for batch processing, querying, streaming, and machine learning, which we will do in this video. Look at these concepts, and it includes all the basic understanding what is Dataproc and how it works. Okay, so you also need to know a bit about Apache Hadoop and Spark. Apache Spark is basically much faster than Apache Hadoop because it uses this random access memory for its computation. So it's computationally heavy, but it is, or it can be like 100 times faster than Apache Hadoop with the same job. So that's why we would basically use this Spark ML, which is based on this Apache Spark framework. So I would create a Dataproc cluster, and I can choose how to do. I click on clusters and I click here create cluster. So I give it a name, let's cluster 2, and I select the region and the zone, and I can also choose how many workers. So by default it is one master and two workers. I can also choose that which CPU cores and random access memory I would like to use. So this also we can do from command line, and that is what basically I would like to show you. As a programmer, you would probably prefer to do it from command line. So I go to the documentation and I click on clusters, and then I click on create to check what are the command syntax for clusters. Okay, so as you can see that G-Cloud Dataproc clusters create, then the name of the cluster and the region, these are basically must. And if you do not give other arguments, then it would take by default, but I would give the other arguments as well. So I have to say num masters equal to 1, number of master nodes in the clusters, so I chose 1, and I chose the master machine type N1 standard because this is the lowest configured cluster, and I chose worker machine type as well, so that I do not cost money much, and like not much resources also is required for this kind of simple jobs. So I create this cluster here and paste this command here, so it would basically create the cluster too. So if we go here and click on Dataproc, again, so it is basically doing the cluster creation. You can see waiting for cluster creation operation. And now if I refresh it, you see that cluster is being created now. So suppose you have run many jobs, and all the jobs would be listed here basically, and you can choose to delete this job history, which you cannot do with Amazon Web Service basically. Okay, so this is very nice feature, I would say. All right, so the cluster has been created. Okay, so you can see that it says created this cluster, and also here the green check mark is there, so it has been created. Perfect. Now what we would do is basically we would deploy our machine learning model on this cluster. So how to do that? We would go to our this BigQuery first and would get all the results into a BigQuery table. Okay, click here, navigation menu, click on BigQuery, and I put the query on this editor, and I put a limit of 10,000. Okay, so it would be much lesser than the 5.5 GB hopefully. So this 5.5 GB when run means that this is the whole data set. Okay, and when I say that I just only need 10,000 rows, then it would be definitely lesser than this 5.5 gigabytes. So if I click run, it would show me it's running. So I have the results here, and I can also save the results, which I would do in this case. And I would save it as a BigQuery table because our Apache Spark machine learning model would read from this BigQuery table. Okay, so I click here, I select the project name, and I select the dataset name. So I choose test checker, and let's give a table name sample. Okay. All right. So if I click here inside the project and test checker, I see that there is a file called sample, which is basically a dataset which we just retrieved. So mother age, father age, gestation weeks, weight gain pounds, and this APGAR 5-minute. So APGAR score is basically is a test given to newborns soon after birth, and it checks basically baby's heart rate, muscle tone, and other signs. Okay, so this is basically the APGAR, which is a abbreviation of appearance, pulse, grimace, activity, and respiration. All right, so we are now all set with our data to run the Spark ML job on our Apache Spark service. I create a directory called Spark ML, and I can go inside this, and there is no file basically, so I create a file here. So this is the name of the file, and I save it here. Inside this Spark ML folder, I've saved the spark_ml.py file before we move it to the cloud environment. Okay, so as you know that we have to use the gsutil command to go to this cloud environment. So basically we use this gsutil function to go to the cloud environment, and we would copy this file natality, or I can also give it a different name, spark underscore, and we are copying to our bucket. Have a bucket over here, and I click navigation menu, storage, and as you can see I have a bucket called Dataproc file, so I would just copy that file there. So as you can see that I have copied this file into our Dataproc folder, and if I refresh it, yeah, so before you move this file to your bucket, you have to basically create the bucket, which is also very easy. So let me show you how you can create bucket. So you click on this, create bucket, and you give it a name, and you follow the process, and you create it. Okay, again, so this bucket name has to be global, so I would give it a name like test Shekhar. Continue. Multi-region means that it would be available all the time, and you do not have any downtime. Storage class standard, and fine-grained is the access control basically. So you would learn later what is basically the access control. It's all about the bucket level permissions basically. And I just click on create, so I would be able to see this new bucket test underscore Shekhar, which I just created. All right, so now what we would do is basically we would submit the job or the sparkML.py file into the cluster which we just created. So our cluster is running over here, and this is my cluster 2, gcloud dataproc job submit pyspark job, and this is the name of the file which we just moved into the bucket. And then I say the cluster name, which is basically cluster 2 in this case, and region and the jar files. And please remember that these commands are in a single line, so there is no new line in the whole command. So I copy this command and paste it here, and I just press enter to run the job on our Google Cloud Dataproc cluster, and it says that job submitted, and it is waiting for the job output. All right, so what is basically our job output? Let's have a look what we are doing in our Python file. So basically we are creating a Spark data frame over here. So this is our Spark data frame, natality data, and we are creating a SQL query to ensure that it doesn't contain any null data. Using this SQL query inside spark.sql method to get the clean data which are containing no null data. And we are then calling this vector from inputs. Okay, so what it is doing basically, so you see that vector from inputs is basically mapping this clean data which we just obtained into two factors like labels and features. As you can see here, labels is basically our weight in pounds, and the features are basically mother age, father age, etc. And then after we have got this training data, passing it to a linear regression model. Okay, and we are putting the iteration, max iteration as 5, and all these required parameters, and we are fitting the model lr.fit and training data. Okay, so here as you can see that these syntaxes are all from Spark ML. This is basically the libraries which we are using, pyspark.ml. There is a documentation for Python. So this is basically the pyspark module. So we are using this pyspark ML regression, and in regression we are using this linear regression basically. So we imported this linear regression from pyspark.ml.regression. So we can do .regression, and as you can see that you can import vectors, or you can do so many basically stuff with that. So you have to basically look at this documentation. All right, so let's have a look at what is basically output. So what we are basically outputting the model summary, coefficients, intercept, and R square. Okay, and also we are showing the residuals basically. All right, so let's have a look at how it looks like. This is the summary of the job basically section, that when it finished successfully and which cluster it used, like cluster 2, what is the cluster UI ID and everything, and this is the jar file which it used. Okay, and this is our main Python file which is basically contains what to do in that job or the job itself. So you can see the output model summary we printed, then we printed the coefficients of linear regression, intercept, and the R square value. Okay, and finally we printed the residuals. So these are the things which we did with these lines of code. All right, so now you are able to run a Spark ML job on Google Dataproc cluster and see the output on the cloud command shell, which is pretty cool. I hope that you like this video, and if it adds any value to your data science education, please do not forget to subscribe to my channel, and more videos on Google Cloud would come very soon. Thank you very much.